Good day once again. This is Basic Mathematics 1, and this is the continuation of our lesson on sets from last week. Now let's proceed. We have here relation between sets. The first one is equal or equivalent sets. Two sets A and B are said to be equal if they have exactly the same elements. Now let's have some examples. Say A is a set of numbers 2, 4, 6. B is a set of numbers 4, 8, 12. And C is a set of numbers 6 to 4. Now let's try to examine each element here in our sets. So we have A and B. If we try to compare them, they have only one common element. And then A and C, they have exactly the same element, which falls for our definition here that equal sets must have the same elements, exactly the same elements. Then therefore we can say that A is equal to C. And we can also conclude here that A is not equal to B or B is not equal to C. Then let's have equivalent sets. Two sets A and B are said to be equivalent if they have the same number of elements. Now do not get yourself confused here with equal and equivalent, though they are synonymous, but when we study sets, they are exactly different. For equivalent, they have the same number of elements. So let's have some examples here. A is a set of numbers 3, 4, 5, 6, and 7. B is a set of the vowels of the alphabet. So you have A, E, I, O, U, and then C is a set of numbers 2, 4, 6. Because we are after of the same number of elements, so let's count the number of elements for A, and we have 5. For B, we have 5, and then for C, we have 3. Therefore, we can say that A is equivalent to B. Or another way of writing it, you can have this symbol here for equivalent. And then we can also say that B is not equivalent to C, or A is not equivalent to C. Then let's have subset. Set A, these are arbitrary set, it can be any set. Set A is a subset of set B if the elements of set A is also an element of set B. So what does that mean? We'll have some examples here to clarify this definition. So you have A is a set of numbers 2, 3, 4. B is a set of numbers 2, 3, and C is a set of numbers 4, 2, 3. Now, let's take a look. It says here any set, is a subset of B if the elements of A is also an element of B. Now let's have B and A. Try to compare the elements. What can you say about it? Then we can say that B is a subset of A. Why? Because all the elements of B is in set A. And we can also say that C is a subset of A. Why? All the elements of C is in set A. And you can also say that A is not a subset of B. Why not? Because one of the elements of A here, which is equal to 4, is not in set B. Now let's have this statement. If A is a subset of B and B is a subset of A, then the two sets are equal. Now let's go back to our examples here. Which of these sets here are subsets to each other? So you can say that A or C is a subset of A, or you can say A is a subset of C. Then we can say that A and C are equal sets, and at the same time, they are equivalent sets. Then you have proper subset. Set A is a proper subset of set B if A is a subset of B, but A and B are not equal. So let's have an example here or some statement here and analyze each statement if it is true or false. Examine whether the following statements are true or false. For the first statement, we have if set 1 is a subset of set 1 and 2, then set 1 is a proper subset of set 1 and 2. Now it says here it is a proper subset if a set A, for example, is a subset of B. Now, the subsets of set 1 and 2 is a null set, set 1 and set 1 and 2. So therefore, since it's a subset, then they are not equal, so that this statement is true. Then let's have the second statement. If set 1 and 2 is a subset of 1 and 2, set 1 and 2, then set 1 and 2 is a proper subset of set 1 and 2. Now, if you see here, they are equal and contradicts to our condition here for the definition of proper subsets that the sets must not be equal, so that this statement here is false. And then the third example. If a null set is a subset of 2 and 3, which is true because an empty set is a subset of any set, then an empty set is a proper subset of set 2 and 3. Since it is a subset and they are not equal, then the statement here is true. Then let's have some note or some statements here that is true for subset. An empty set is a subset of every set, and it is a proper subset. And then the second one, a set itself is a subset. The number of all subsets of a set A is equal to 2 to the power of n of A. This n of A here is the number of elements of set A. And then you have here, I've already given this earlier, if A is a subset of B and B is a subset of A, then A and B are equal. Then let's have power set. Power set. When you say power set, it's a superset, meaning that all the elements of a power set is in the form of a set. So let's have this. Power set is a collection of all possible subsets of a given set, and it is denoted by P of A, or the power set of A. And then if you have n of A is equal to x, then n of the power set of A is equal to 2 to the x. So that is actually, this one is the cardinal number of the power set A is 2 to the x. Then let's have some examples here. So you have A is equal to the set of A, B, which implies that n of A, or the number of elements of A, is equal to 2. So if you count that, there are only 2 elements here of A. And then our number of elements of our power set of A is equal to 2 squared, or 2 to the power of 2, which is equal to 4. Now, if we are going to list all the elements of P of the power set of A, or P of A, then you can have P of A is equal to the set of empty set of A, set of B, and then set of AB. Let's have some examples here. Another example here, you can have B is equal to the set of numbers 1, 2, 3. That implies that n of B is equal to 3, so that the number of elements of your power set of B is equal to 2 cubed, or 2 to the third power, which is equal to 8. And if you are going to list all of the elements of the power set of B, then you will have a null set, set of 1, set of 2, set of 3, set of 1 and 2, set of 1 and 3, set of 2 and 3, and then set of 1, 2, 3. Now let's have important statements to remember here. For any set A, every element of P of A, or the power set of A, is a set. And then for any element A, the number of elements of the power set of A, or n of P of A, is equal to 2 to the number of elements of A, which is equal to the number of subsets of A. And then null set is an element of the power set of A for any set A. Then A is an element of the power set of A for any set A. And then the power set of A is not equal to a null set for any set A. And then for any set A and B, if A is a subset of B, then P of A is a subset of P of B. If both set, this means that if two sets are subsets to each other, then the power set of each set are subsets as well. Then that's the end of our discussion. I want you to try to answer. This is your worksheet 2, and I want you to try to answer this in your notebook, and I will check that by the time you come to school in July. Thank you very much for watching this video, and I hope you understand the lesson.